This differential equation is of the form y prime plus p of x times y equals some other function of x. Consequently, we will use an integrating factor. You integrate that p of x, and then you use that as an exponent on the e function. So this 2x is the px, so we need to integrate that first of all, which is x squared, of course, and we don't need a plus c, we'll do that at the very end. Then the integrating factor is going to be e raised to that, and then what you do is go back to the equation that we were given, multiply through by e to the x squared. So we will have e to the x squared times y prime plus a 2x times e to the x squared times y, and on the right hand side x times e to the x squared. So this came from the product rule. Somebody had a product of two things and took the derivative. One of those things has to be y. Here they left the y alone and they took the derivative of the other function to get this. Here they took the derivative of the y and they left the function alone. That means that what goes in here is the e to the x squared. And you can even double check, take the derivative of this, so in the product rule, leave the y alone, there. Take the derivative of this, derivative of the e function will be the e function, then because of the chain rule, derivative of this is the 2x. Perfect. And now integrate both sides. On the right hand side, this is a pretty straightforward u substitution, or another way to look at it is the derivative of this is this with a 2x in front. So in other words, going backwards, the integral of this would be just the e function. So if I just had a 2 in front, that would be exactly what this is. So what I could do is put a 2 in front and compensate by multiplying by a half at the same time. Or if you do u substitution, it will do the exact same thing for you. So you'd have a 1/2 in front, and now the antiderivative of this is the e to the x squared function. And the integral on this side, it just gets rid of the derivative. We have e to the x squared. And we need a plus c in there now that we've integrated. So finally, to solve for y, just divide by e to the x squared, so get rid of this. It's going to actually cancel this, but you also have to divide here. So it would leave a 1/2 plus a c divided by e to the x squared. And most likely, if you look in the back of the book to see an answer, they wouldn't leave it like that. They would most likely write it as c times e to the negative x squared plus 1/2.